be respectful of everyone's lunch hour here, so we'll go ahead and get things kicked off. I'm Allie Condren, and Smith. I've got two names. It's very confusing. So, but I work for Genesis, and I've been with the company for over 3.5 years now. But before that, I like Quovum, worked for a value-added reseller. So I've been in the Genesis ecosystem for about 15 years now. Genesis is a global contact center provider. We are largely focused on cloud, been around for 30 years. And so I want to allow Carl to introduce himself, and then we'll get things going.
Thank you, Ali. I'm Carl Veros, Solutions Consultant for Quovum C3. The entire Quovum team is happy to sponsor this webinar today, and we hope you find it to be useful and entertaining. Quovum C3 brings a wealth of knowledge to the contact center industry with over 50 qualified employees. Our focus is contact center solutions deployment, professional services ranging from simple to more complex AI applicative integrations, training and support. Back to Ali.
Thanks, Carl. So we've got two topics today. So why it's time to make a move to the cloud. So we'll focus on that first. And then second, let's talk conversational AI. I want to make sure if you have any questions, feel free to use the Q&A at the bottom of the Zoom window. And we'll let Randall go ahead and get things started.
Good afternoon, everyone. My name is Randall Cuttrow, and I'm the Senior Solutions Engineer for Quovum. And today I'm going to be talking about why the cloud and getting ready for the cloud. Why are we going there? Why are we there? And why does I've got about 25 years experience in IT, about 20 in contact center and about 16 or 17 working with Interactive/Genesis. So I like to tell people I grew up in the contact center world. All right, moving right along. So why is it time to move to the cloud is what the topic discussing. And in order to understand the whys, you need to kind of understand the history. What's interesting is the development or the migration to the cloud is really my history. It is my history and how my career has evolved. And I'll talk about that and relate to how my experiences has actually mimicked what's happened with the cloud. So the drive to e-commerce. Well, when I first started working in contact centers, many contact centers had server rooms that were full of servers that would serve out the applications required by the agents to handle calls. So there's CRM, maybe their ticketing environments, and also the phone system that would handle the automated call solution for the contact center. And then as e-commerce started to become more and more prevalent around the turn of the millennium, we saw more companies starting to build their e-commerce solution. And what that entailed was building web servers that could provide an e-commerce experience for the customer. And so businesses started growing those e-commerce environments in their data centers. But the problem with that is those data centers weren't really designed to grow as quickly as e-commerce demanded, and also as the whole e-commerce business started to grow, we saw businesses outgrowing their offices, outgrowing their data centers, and so something had to give. At the same time, we had telcos developing technologies that allowed customers to connect to remote data centers using private WAN technologies. The most prevalent would be MPLS and Layer 2. So MPLS being a protocol that allowed us to connect to many different sites and build a private cloud that connected all those sites. So you could have a data center that had all of your technology in it. You could have your main office that had all your business people. You could have another office that was your contact center, and they could all be connected together using MPLS technology. Layer 2 was much more direct, so it was a point-to-point technology. But the point of the matter is these technologies allowed businesses to take their data centers and move them off-site, which allowed them to grow dynamically. They could secure the data centers, and they could build stronger and much more powerful e-commerce environments. And of course, I just mentioned it, but the concept of co-location came into view, where businesses would take their data centers that were located on site, and they would buy a slice of space in a co-location facility. These co-location facilities were designed with backup power, backup access to the internet, as well as great access to services like MPLS and Layer 2, so that customers could come in and buy a slice of that space, host their technology there, and connect to it with those technologies I just spoke about. What eventually happened, though, is the amount of servers required and the amount of space to host those servers became daunting. So along came the virtualization technology, where servers had become so powerful, rather than having a physical server hosting one virtual server environment, we could host several virtual server environments on one physical server. That made the footprint required inside of a data center shrink, and it allowed customers to build much more powerful e-commerce environments and grow what they were offering to their customers in their e-commerce environments. So because these data centers became so much more important to the customer, well, then they started thinking about, well, if I lose my data center, what happens? So then we started looking at replicating data centers. So we would have two, and one would back up the other. Systems would be replicated across those data centers. So if one data center was lost, the other one would continue going. Often this was done, maybe one in North America, one in South America, maybe one on the East Coast, one on the West Coast. In North America, that's often how we do it. In Europe, it could be in different countries or on different continents. But geo-redundancy really allowed businesses to ensure business continuity during major disasters that areas where data centers are hosted could experience. And then we had the Great Recession. And this was a very interesting time for myself. At the time, I was working for a company called Register.com, very large contact center here where I live in Yarmouth, Nova Scotia. There was 350 outbound seats. We had 100 inbound seats. And we were a .com hosted out of New York. So it was a very, very big business, and the recession hit. And just like all of these other e-commerce, of course, Register.com does they're a domain registrar, so they are key to e-commerce. But a lot of these other businesses started looking at all of the equipment that they had purchased, all the CapEx expenditures that they had put in place to support the e-commerce, and then facing, after the Great Recession, 50% or more reduction in the amount of business that they were getting from customers. So that left them in a really bad spot, where they had invested a lot of money in CapEx and were forced to depreciate that capital expenditure without having the revenue to support the infrastructure they had built. And that was a big problem with the Great Recession, because as businesses retooled to kind of deal with the shrink that came after the Great Recession, because there just wasn't as much money around, they found themselves with all this technology they didn't know what to do with. And they also couldn't just throw it away. They had to depreciate it. And so you saw C-level management talking a lot more of, okay, we need to get away from capital expenditure and more OpEx style solutions. And this is where cloud computing started to be discussed. Okay, rather than having us hosting our own applications, what if we were to purchase an application or rent an application as a service? What if the application was sitting on the internet and we just bought a slice of that and hosted what we needed inside of that cloud computing environment? So the concept of a SaaS started to be discussed. So, solution as a service, where rather than building a complex server room or a data center to host your e-commerce or your solutions that you needed to support your customer, you simply went out and found someone that could build your e-commerce environment that could host it as a service. The advantages to that is, well, if your business grows, you simply pay a little bit more and they provide more resources to support your e-commerce environment. If you shrink, then you pay a little bit less. You don't need as much licensing or whatever the model is. And the provider of the SaaS simply shrinks the amount of resources available for your e-commerce environment. And so then we saw the march towards the cloud. And this was an interesting time for me. I mean, one of my biggest backgrounds is Active Directory and Exchange. And I can remember when Office 365 came out, and I looked at it and went, there's no way that a lot of businesses are going to move towards moving their Exchange environments into the cloud or their Active Directory environments. These are key to their businesses. But that's exactly what happened. And boy, was I wrong. So we saw a lot of early adopters, Microsoft with Azure. So what Microsoft did was they took the exact same infrastructure they used to support their Office 365 and Azure AD offering, and then they started building a application hosting environment called Azure that you could buy a slice from. So you could go and you could host a microservice, you could buy a hosted server where you could put your own code on, or you could have your code hosted. It really depended on what you wanted to do. Amazon Web Services did the same thing. At the time, they were a major retailer. They had made it through the Great Recession. And the way they did that was they had an amazing e-commerce environment that they had built themselves, and they had built it in such a way that it could deal with the Great Recession and the whole CapEx to OpEx march. And so they started selling slices of that to potential customers, businesses that wanted to host their e-commerce environments. And so we saw Amazon Web Services taking off as an early adapter. The key to both of Amazon Web Services and Microsoft Azure, these big players, the key is a concept called the elastic dynamic load balancers. And what that really means is that these platforms, what they do is they monitor the required resources necessary to support the environment that you're hosting and dynamically add or subtract resources necessary to support that environment at any given time. So what you need to imagine is there's a pool of resources, and each customer coming in AWS or in Microsoft Azure is drawing from that pool, and the amount of horsepower to support your environment is dynamically added or subtracted based on the requirement. This is key because this really allows us to move into an OpEx world without worrying that we're going to run out of resources to support the customers we need, or invest too much in infrastructure to support growth that later we experience shrinkage, and then all of a sudden we're left with infrastructure that we don't necessarily need. Microservices became very popular. So rather than you hosting, maybe getting a web server or a server built inside of these environments, maybe you just needed the application like a DNS service or an e-commerce environment or whatever. So then we saw microservices, basically these little tiny services that are required to provide an e-commerce environment were presented themselves as a service rather than the infrastructure to support them. And then the idea of the cloud-based contact center became more and more prevalent. If you think about it, the contact center world is really, even though traditionally we've had to focus a lot on CapEx expenditure to build contact center environments, the business model really lends itself towards being more OpEx. And when we moved away from contact centers simply being call centers, where people were contacting us via SMS, or contacting us via email, chat, and now social media. Well, locating our contact center solution in the cloud allowed us to be much closer to all the other tools that we need in order to provide that experience. For example, I'll talk a little bit about Genesys Cloud in a minute, but one of the products that we sell and support every day, Genesys Cloud, because it lives in the cloud, it can easily integrate into CRMs to pull and push data. It can easily integrate into artificial intelligence, which Peter will talk about later. Moving it into the cloud brought it one step closer to having access to all the resources required to provide that seamless single pane of glass experience that the agent required to effectively handle the customer. So how did this happen? Well, first of all, we saw the internet becoming far stronger. So one of the biggest issues with moving a contact center into the cloud is you need to start moving voice across the internet. And traditionally, we protected voice across WANs and LANs, so customer data networks, by using something called QoS, by giving priority to the voice. So literally, in a customer LAN or a WAN, so an MPLS layer 2 or their local data network, we would deploy QoS, which would move the voice traffic first and everything else second. But across the internet, you can't do that because you can't give, there's no, the internet doesn't support QoS. And the reason why it doesn't is because, well, how can you say your traffic is more important than anybody else's? It's a public network. So the internet itself started to become much more resilient. We saw this starting to really take hold about 10 years ago, 11 years ago, when things like two-way FaceTime videos started to become more prevalent. I mean, FaceTime, Skype, all these different services, and they started in the consumer world, and that's where they became stronger and stronger, where they became good enough where we could start using them in the contact center space. We also started migrating the applications that we use in the contact center to cloud, to web-based apps. So, for example, the applications that supervisors and managers use, the applications that the agents use to handle the call. Everybody's heard of the soft phone, the software-based phone, but then there's the concept of the web-based phone that became developed. So you had a phone that was basically accessible through a browser. And in order to tie this all together and to ensure we had the best experience possible, like I said, we had the WebRTC phone, which was a web-based phone, browser-based phone, so there's no software install or anything. And layered on top of that is the Opus codec. So what is Opus? Opus is a really interesting codec. Traditionally, when we move voice across data networks, we usually use G711, which is no compression at all, or G729, which is, there's quite a bit of compression there, but it's static compression, meaning that the compression is set and it doesn't change. Well, what Opus did was Opus dynamically compresses the audio signal based on the quality of the network connection. And the best way I can explain this is if you're speaking to someone overseas from, HP or Microsoft or someone like that, and you're speaking to them and it sounds like they're kind of hollow and far away, but you can still understand what they're saying and there's no packet loss, well, that's Opus at play. And every once in a while, maybe their voice gets a little bit clearer and then it goes farther away again. That's Opus making sure that it doesn't drop any packets, so it adds compression to make sure the call can still happen. Opus is used a lot to move calls over long distances across the internet now, and it is key to ensuring that we can have clear and concise conversations in a contact center world with agents working from home or in the office using cloud-based contact center solutions. So where we are today, well, where we are today is the march towards the cloud. We're seeing a lot of contact center solutions now moving into the cloud. In fact, that's what we sell and support ourselves. We're seeing a lot of integration into a lot of other technologies that are available on the internet to provide a better experience. I talked about that earlier. And one of the hottest topics, which my friend Peter is going to talk about in just a second, is going to be the whole artificial intelligence piece, which is really providing as close as we can a human experience for our customers, but doing it with machines instead of people. And why are we doing that? Well, I mean, what Peter will talk about will kind of allude to that. But at the end of the day, we're faced with the amount of interactions that contact centers are facing. It's actually going up. We're looking at different media types. It's increasing. And so therefore, contact centers are having a harder time finding enough agents to answer all those interactions. So we have to come up with creative ways in order to allow machines to answer customers whenever possible. And artificial intelligence is a way to do that. And of course, those that were early adopters of contact center solutions in the cloud, they were very successful at sending their agents home during COVID. So, now those that haven't been early adopters to cloud-based contact center solutions have really suffered during COVID because, of course, they couldn't have their agents working from home, or they had to scramble to put technology in place. Those that were on those technologies simply sent their agents home, and a lot of times with nothing more than a headset. As long as they had an internet connection at home and some type of a PC environment at home, they were ready to work and to deal with working from home. That's pretty much it. Any questions?
So Randall, I'm just joining in. There are no open questions at this time.
Okay.
Keep moving on.
Tell me when we move along to conversational AI.
Ready to go, Peter.
Okay, so folks, I hope you do have some questions that come up. It's kind of funny talking out into the ether like this. But moving on to our next topic is artificial intelligence. And can we use it to make life easier for our customers contacting us through the contact center? Yes, there is. We call it conversational AI, and Quovim is happy with our partner Genesis to bring you some thoughts on that today. So let's talk. So we begin with the model of language, how people speak. And we'll tell you that when two people talk, they use what we call natural language, simple, what I'm doing now, natural human expression. So let's take a look here at what used to happen back in the day when Mrs. Smith called the Acme product corporation, the folks you're all familiar with from Bugs Bunny cartoons. She called Acme, and Helen, the switchboard operator, answered. And she said, "Hi, and welcome to Acme Corporation, inventor of the jet-powered tennis shoes. How may I help you today?" And Mrs. Smith stated that, "Well, I think there's a problem with my bill." Helen was quite surprised to hear this. "A problem with your bill? What seems to be the trouble?" "Oh, I was supposed to get a discount," said Mrs. Smith. "Oh dear, let me get you to accounting right away." And she pulled out a few plugs and plugged in a few plugs and got her to Mildred down in accounting, who was shocked that no discount had been applied. And so let's take a look at what really happened here. So the characteristics of a human-to-human conversation, there's clarity. Things can get resolved quickly. One hopes that there's a constant courtesy and empathy on the part of both callers, and things can go fairly efficiently. Unfortunately, for a company to deploy two employees for a single call, that's kind of pricey. So that lasted as long as it lasted until somebody came along and invented a software solution, which we call IVR, or interactive voice response. So let's take a look at this same situation when Mrs. Smith calls Acme Corporation and hits an IVR. The IVR answers the phone and says, "Thank you for calling Acme Corp. Our menu options have recently changed, so please listen carefully for the beep before making a selection. Your call is important to us. For our opening hours, say opening hours or press 1. And this goes on for a little while, and Mrs. Smith gets a little bit tired of it, and after a little while she hits 0 because she wants to talk to somebody, and nothing happens because she hadn't heard the beep yet. And this goes on for a little while longer, and Mrs. Smith is getting a little frustrated, hits 0 again. Finally, she hears, say other options are press 9, hears the beep, and she hits that 9 pretty hard. And that leads to another menu. The IVR says to her, "You've selected other options. To report a lost or stolen Acme Fidelity card, say lost card or press 1. And this goes on for a little while until Mrs. Smith hears to speak to an operator or a representative, say operator or press 0. She hits 0 pretty hard. And finally, when she hears that beep, she hits 0 a bunch of times. She is not pleased any longer. At this point, the IVR responds to her and says, "Please wait while we transfer you to our next available representative. Our current wait time to speak to an agent is 18 minutes. And then some music starts to play. And by now, Mrs. Smith is gritting her teeth in frustration. So what happens here? So the characteristics here are, there's some good news. Services are automated. And that is nice because this is an inexpensive use of company resources. On the other hand, the interactions are menu-based. So the interaction is driven by the IVR, not by the customer. Navigation isn't always great. In this example, you can see navigation took 3 menus. You might think I'm making this up, but we've all experienced this or worse. Options are not always placed conveniently for the given call. We try, but we don't always, place them conveniently. And there are sometimes some pretty lengthy waits leading to user frustration. And ultimately, excuse me, as happened in this case, the automation rate wasn't great. We ultimately did have to go to an agent anyway. But the really important factor I'd like to point out to you is that the automation, the interaction is driven by the IVR and not by the caller. So what do we do about that? Well, I think we'd all agree that natural language is just nicer. So let's take a look at some conversational AI in the form of chatbots and voice bots. These are applications that understand natural human speech, natural language, and they can make sense of what we say, inferring intent, the subject we're talking about, and even some connected information sometimes. So there are 2 forms. First is a chatbot. It's text-based. This image is a little bit blurry, but it's the kind of thing that would appear on the screen of your phone or the screen of your computer. And the chatbot opens up and says, hello there, what can I do for you today? The user types in, find me a clinic near me. And in response to that, the chatbot puts up a page showing the Get Well Soon clinic nearby, even with the opening hours and its level of occupancy at different times of the day. A chatbot can do that. A voice bot is a similar beast, but it handles actual human speech. So for instance, when this woman calls the hospital to order flowers for her sister who's just had a baby, the chatbot can take that text and respond very, very cleverly. So, she said her sister and just had a baby. Well, there's a cue to say, congratulations to your family. How about a special newborn joy bouquet? It can check, this being an application, it can check the delivery times available and says we can deliver those flowers to room 206 this afternoon. This is an example of some very good user experience design. But the important thing that I'd like to point out is that the initiative is now back in the hands of the customer. So no more lengthy waits. So let's go through another exercise here and take a look at Mrs. Smith calling Acme Corporation again. She will hit a voice bot this time. She's still a little unhappy about the call she had with the IVR, so she's not in a great mood. And when she dials up, she hears, hello and welcome to Acme Corporation, home of the jet-powered tennis shoes. How can we help you today? Mrs. Smith responds tersely, there's a problem with my bill. Chatbot hears that. It says, the voice bot, I should say, hears that and says, okay, a problem with your bill. I see in your file that you that you recently purchased a box of earthquake pills. Yeah, that's a big seller at Acme Corp. Surprised, Mrs. Smith has had her recent purchase acknowledged and says, yes, exactly, but I didn't get the 15% discount you promised. The chatbot voice bot hears that and says, you're right, no discount was applied. I can fix, shall I credit your account? So this is an interesting conversation. And of course, Mrs. Smith is pleased and says, of course, certainly, yes, thank you. Now, let's take this apart and see what happened here. So first of all, we're talking to a voice bot. So there are no menus. We don't impose lengthy waits on users. We want our users, our customers, our callers in this case, to simply state their business. Why are you calling? How can I help you? What can I do for you today? The answer is understood as an example of natural language and free expression. And then the voice bot employs some pretty good user experience design. First thing, you echo back the user's concern. Okay, a problem with your bill. It can take a look at the customer history and see what recent activity has gone on and says, well, I see that you purchased a box of earthquake pills. Displaying empathy, of course, is important. You want your applications to always be respectful and empathic. You're right. And finally, check out some business rules. Mrs. Smith is a very good customer. We're going to offer her that discount. Sure, I can fix that. Shall I credit your account? A much more effective and humane interaction. the kind of thing we'd like to be able to offer to all of our customers. And increasingly now, with using this technology, we can offer this kind of an experience. And notice it didn't have to go to an agent. So you have free expression and saving agent time. So at this point, you might be wondering, how exactly do we achieve this understanding of natural human expression of natural language? And it's done using an artificial intelligence technique known as machine learning. It was invented in the 1950s. We may remember perhaps examples of it in the 1990s when IBM's Deep Blue beat Garry Kasparov, I think it was, the chess champion. And the technique that was used there was not a rule-based approach to chess. It was, having examined thousands and thousands of games, it applied machine learning to come up with its own strategies. So and now in the last few years, it's become available commercially to people to use this kind of technique. It needs a lot of data. You have to be able to examine a whole lot of different scenarios and parse them, build them into something called a neural network that's inside the machine learning engine itself. It employs some fairly sophisticated mathematics. But the key, of course, is the data. So we're talking about real world data and the data that's pertinent to the application we're building. Real world data, there's a lot of that out there. And many of us, or all of the machine learning engines out there, come packaged with that. The key, though, is how do we build up a set of data that represents your application? Let's have a look at that. And I see there's already a question in the Q&A, which I'm grateful for. Thank you. I can't wait to get there. So your app's data. So first of all, data, you build it into something we're calling a corpus. What is a corpus? Well, you take your data and you have to come up with a collection of the intentions that people express when they're reaching out to you. A dentist will have a collection of intents, typically to do with mental matters. An insurance people will want to maybe ask for quotes or report problems. But the point is, you need a lot of examples that. So having that, you feed that into the machine learning engine, and as it receives input from your users, it can come back with concise results, change of address, lost card, or maybe book appointment. We're going to look at that in a little more detail. So your application's data, what does it look like? Well, for a change of address, you might have people saying, I need to change my address, or I have a new address, or I'm moving. I don't live there no more. You'll notice that in those examples, only 2 of them had the word address, and only 1 of them actually said change address. So human beings have a tendency to be a little bit unpredictable on how they're going to express any given need or intention. That's one example. Let's look at lost cards, for instance. I think my card was stolen. I can't find my card. I lost, or my son lost my card. Can you just send me a new card? All of these would relate to a situation where people might have lost their card. Booking appointments. I'd like an appointment. Pretty easy. If you're a dentist and you receive a call that says, I have a toothache, that means that person probably needs an appointment. Your website said I should come and see you. When can I meet with my advisor? These are all ways in different contexts of expressing the need to book an appointment. Now, where do we get the raw data for this corpus? Well, we know that every single contact center in the world keeps meticulous records. Every contact that comes to it, with full transcriptions and recordings, and every call is tagged with a reason. And so that's a great source for building up a corpus. If, on the other hand, you live in the real world and the data keeping isn't quite that up to date, well, it doesn't matter. There are recordings. Go to the recordings, listen to them, transcribe them, and build up your corpus from those. If you don't have recordings, well, there's a way of getting them. You could deploy an application that simply says, how can I help you? And then immediately transfers the call to an agent. You don't want to leave this out there for very long, but while it's out there, it's recording what people say. You take that, you give it to your transcribers, and they list it all out, and you can build up your corpus from there. Again, you don't leave this thing running very long, but for a short period of time, in order to get enough of a sampling to build up a corpus, that's a strategy that's used quite a lot. On the other hand, if you don't have any means of getting recordings, you can always rely on your SMEs, your subject matter experts, your people from within the organization who understand what is being offered, who can make good educated guesses about how people will ask for different services. You can build up a fairly, well, not a hugely robust, but a beginning of a corpus with that. You deploy this, and you then tune based on the real world data that you receive. It doesn't take a lot of data to start seeing some really nice results. For each intent, you're not looking at thousands and thousands of different recordings at all. You're looking at tens, if you want to be really thorough, a few tens. I won't even say hundreds. It's hard to know exactly how many, but you can build up a corpus with data from the real world and start making your recognition engines pretty robust pretty quickly. So that's the data side of artificial intelligence, conversational AI. In the end, of course, you've got to bring all this together. So there are solutions that do the interpretation, the understanding of the natural language that are available online from some very reputable companies, IBM, Microsoft, Amazon, Google. There are even solutions that you can have on-prem from a company called Rasa. Here we're going somewhat against the arguments that Randall was making earlier, but it is a possibility. And these packages, they come packaged with real world data and all that sophisticated math that I was talking about. What we do is we simply feed them in your own data from the corpus. And then having done so, we know we can get good recognition of natural language. We need to tie it all together. So we need to worry about things like any project, requirements gathering, user experience design, integrating everything into your own existing architecture, and then developing the applications. And the folks that do this need to be concerned with things like, well, designing front ends and writing the right connectors to back-end systems. So that's really where we're coming from at Covim. Our services are such that we can connect to any of these services, and of course custom tie in to the existing infrastructure in your environment and make it all live within the Genesis cloud. I'm coming to a conclusion. I just see the time is pretty good. I hope we can have some robust conversation after this. To sum it up, we recognize that contact centers are pretty complex entities. There's a lot going on there. You've got to worry about a bunch of things: skills management, clearly, call routing, setting up your agent queues and managing those. You may be doing web chat within your contact center. There are obviously traditional IVRs out there. You probably have some callback services or even outbound call campaigns. You're probably answering a certain amount of email in your contact center. The new player on the block, however, is this more natural, higher performance entity known as a bot. Chatbots and voice bots that can help your users automate more of their activity, more of their needs, and do it in a way that is convivial for them, that they feel things move along naturally and they can get to a conclusion with an automated service more frequently than they would necessarily with an IVR or naturally back when Mrs. Smith called Helen at Acme Corp. The lessons we can draw from this are that a voice bot and a chat bot can give the initiative back to your customers. They state their needs and get the answers they need without having to wait without having to listen to menus, without having to navigate 2 and 3, 4 levels down. We can provide a really exceptional UX experience to our callers and our users. We do need to organize our data, that's a given, but we can reach out to technologies that are delivering these results today from, some pretty big players. And the cost of these is really nominal. We're talking about fractions of cents for each interaction. So having all that, well, of course, you need to bring it all together, and that's where we hope we can help you. So I leave you with one final question, and I hope that you will come back to me with, and Randall, with many questions too. Really, shouldn't we be talking? Thank you for your attention.
Thank you, Peter. We do have a question, and I believe, Randall, you may want to answer that one.
Yeah, I'll take that one. So the question is, how do we ensure customer data is protected in cloud contact center? The answer is actually a lot easier than you may think. So when in a traditional contact center, when you want to protect your data, you have to worry about protecting your data in your data center, and adhering to the standards that you can prove that your data is protected. When we move the contact center into the cloud, then we're making use of the security protocols and the methodologies that companies like Azure AD and Amazon Web Services have developed. And because these applications are multi-tenant, which means you have one environment with many customers using that environment, then you can pour all your resources into securing that one environment and making sure that your data is safe. I could talk about the product that we sell and support, Genesis Cloud. All the data is actually stored in Genesis Cloud, all the customer data, all the information. And Genesis is fully compliant with several different security protocols to ensure that data is safe. When you move data, so what about when we're communicating across to the cloud? So for example, the information we're sending back and forth to the client application or the actual conversation in the voice over IP. Well, so if we talk about voice, we leverage TLS. Basically, we refer to that as secure SIP. So the SIP communication is secured, and then we use SRTP to secure the audio portion to ensure that is secured. The traffic back and forth across the internet to the clients, we rely on SSL using HTTPS. So really, we secure the data back and forth as it's being fed into the cloud. And once it gets into the cloud, because everybody's using the exact same environment, all the customers, like I said, it's a lot easier to actually secure that data. Let me know if that answers your question, or if you have any other additional questions.
Thank you, Randall. Peter, not sure if you can answer this one, but are there limitations to implementing AI within a contact center? As an example, number of agents?
Right, well, that's a provisioning question. In terms of number of agents, no, there are no technical limits. Each interaction costs fractions of pennies. So there might be budgetary questions there. Really, the biggest limitation is how much traffic you can get on a given subject, so that you can model the necessary recognition and the necessary feedback to whatever you've understood. I just want to emphasize the importance of UX design. These, in a way, you can think of it as, we've spent decades refining our computer-to-computer protocols. Now that we're bringing another element into the equation, us people, human beings, those protocols, if you will, need to be very carefully thought through and designed. So it's really a question of good UX design would be something that we need to think about. But in terms of limitations, the number of agents that could be hooked into something, a previous layer of communication using AI, there are not technical limitations to that.
Thank you. And we have another question. Would Genesys or the vendor hosting have access to customer data?
It depends. They don't have access unless you permit them to have access. And I'm talking about Genesys here. I can't talk about other vendors. So access to that data is at the discretion of the customer.
Yeah.
Any more questions? Well, time flies. We hope you enjoyed the webinar. Your comments are always welcome. We'd also be happy if you shared specific topics you would like to know more about in the near future. You can reach out to myself or Ali by email and we'll gladly answer back. And I believe we'll be able to share. Thank you very much. You see our contact information on screen now. On behalf of Ali Condron-Smith and the Genesys team, as well as Quovim C3 and our panelists, Randall Cotreau and Peter Modesto, thank you once again and enjoy the rest of the day. We look forward to seeing you soon. Goodbye, everyone.